So, very good afternoon. I'm going to present the topic. The topic name is digital image processing. Hello, I am Dr. Parimal Shah, the assistant professor of Department of Electronics and Communication Engineering from the Purnia College of Engineering, Purnia, Bihar. So, that is the learning outcomes. So, after going through this topic, the student will learn about how to explain fundamental steps in digital image processing. They will be also able to describe elements of human visual perception, learning, light, and the electromagnetic spectrums. And after this, they can they will be able to analyze image sensing, acquisition, and acquisition processes. So after all, they will be able to represent digital image and they will interpret resolution concepts also. Coming to the contents, so these are the contents which goes according to the learning outcome. So coming to the first topic, elements of visual perception. So in digital image processing, an image is called the problem domain. Here you can see, and the image is first step is to acquire the image. So this is called image acquisition, which you will study in chapter 2 of this book, Gonzalez. And after that, once image is getting acquired, it has to be filtered. So image filtering and enhancement. So filtering can be done in two domain, spatial domain as well as frequency domain. So after that, image restoration is done. Once image restoration is done, there is color image processing based on different colors. Its intensity values has to be stored in different colors. After that, there are so many different kind of higher level processing like wavelet processing, compression, morphological processing, segmentation, representation, and object recognition. So coming to the next point, elements of visual perception. So in this nature, eye works as a acceptor, like a image processing thing. So what happens when light passes through this lens of the eye? It is getting accepted by the retina, and retina works as a small small pixels of the camera. So the data is presented on the retina, which is getting accepted by the brain, and brain reproduce the same image which is coming through the lens. So there are these different sections of the eyes are being shown here. So the very first step to understand how an image is formed is the eye. So next is light and the electromagnetic spectrum. So how it works, how light forms an image, and what are the different sections of light, what are the electromagnetic spectrums. So there are five kinds of electromagnetic spectrum. Starts from the based on the wavelength. It has been divided into five parts, that radio wave, microwave, infrared, ultraviolet, x-ray, and gamma rays. So uh, when going to from radio waves to gamma rays, wavelength reduces and frequency increases. Okay, and based on this different wavelength, different kind of imaging is also being used. Like radio waves are used in radio astronomy and MRI imaging. Microwaves are being used in radar system and satellite imaging. Like infrared is used in thermal imaging or medical diagnostic. Ultraviolet is used for forensic analysis and industrial inspection. X-ray is being used in medical radiography, security security scanning. And gamma rays are being used in cancer treatment and nuclear medicines. These are some examples. However, there are so many more examples which are not being seen here, and it is being used extensively in the world of science. The fourth is image sensing and acquisition. So, how image is being sensed by a pixel. So here it shows, this cartooning view shows a small one pixel. So one pixel means one photo detector, where the energy of light from one image is collected by the photodetector, and the output of photodetector comes as a voltage waveform out. So this voltage is the represent the intensity of light coming from the image. And when we took the array, linear array or two-dimensional array, it forms the camera section, the sensing part of the camera, two-dimensional sensing part of the camera. So how it is being represented? So we represent in two dimension x and y dimension the picture. So each coordinate point represents the position of a pixel, and at each pixel there will be some intensity values of that image. So the intensity values is being shown in the third dimension here as a fxy. So intensity values can vary from 2, 4, 8, 16 in the form of 2 raised to n. So based on this intensity and space, there are two types of image resolution. First kind is the spatial resolution of the image. And here is the unit of spatial resolution is dpi, dots per inch. So suppose this is one image and its number of pixels in x and y direction are fixed. Say it is thousand by thousand. So in this thousand of thousands pixels per inch, how many points are there? How many pixels are there? That represents the DPI. So 1250 DPI means in 1 inch there will be 1250 dots, 1250 pixels. So it is highly dense pixels, and in 300 dpi there are some smaller number of pixels in 1 inch. So when we reduce the dpi, its spatial resolution decreases and the quality of picture is getting diminished. Here you can see the last one is the worst quality of image. So next is the spatial intensity resolution. So how we define for a given pixel, number of pixels is fixed here, but the intensity values can be represented in higher levels or and lower levels. When it is shown by 256 levels, it is high resolution, high intensity resolution image. When it is being represented in lower values like 128, 64, or 32 levels, the image is reduced in the intensity resolution. So the last one is the reduced intensity resolution, and the first one is the highest intensity resolution we can see here. So summary is that we understood the what are the steps of image acquisition, how it is being represented, what are the different processes for the image processing, and we explained how human eyes works, what is the visual perception, how light is getting accepted by the iris, lens, and on the cornea, how it works like a camera. And we describe the light and the electromagnetic spectrums, different kinds of spectrum based on wavelength and frequency, and the applications of the image in these areas. After that, we understood the image sensing and acquisition methods also, and the array of the image sensors. After that, we represented images using pixels and intensity values. So once we represent the pixels, we tried to understand the what is the resolution. Two kinds of resolution. One is spatial resolution. When in a space, number of dots per inch is increased, spatial resolution is increased. And when the number of pixels is constant, but the intensity levels are being increased or decreased, we say intensity resolution of the image is increased or decreased. Here are some questions for the assessment and which student has to do at the classroom. So thank you very much.